And today we're going to start learning about naming compounds. So this will take us about 3 videos, kind of a big topic. So this is the first of 3 videos on naming covalent compounds and ionic compounds. So, naming compounds. Before naming a compound, you first have to recognize what type of compound it is. Very first thing you have to do, find out which type of compound is it. And there are 2 types of compounds. Number 1, ionic compounds. Ionic compounds, in a very general sense, are metal, nonmetal, or metal polyatomic ion compounds. Second type of compound is molecular compounds, commonly called covalent compounds. So we have ionic compounds and we have covalent compounds. Okay? Molecular compounds or covalent compounds are generally non-metal compounds. So just a note here on naming compounds and how this topic can be much easier for you. Naming ionic and covalent compounds is much easier to learn if you already know the names and the symbols of the elements in the periodic table. Flashcards are a great way to learn the elements on the periodic table. So it's a lot easier if you already know the names and symbols of the elements. Alright, so number 1 at the top of the page was ionic compounds. So let's dive deeper into number 1, ionic compounds up there. So naming binary ionic compounds. So these are ionic compounds that have 2 types of elements, binary. Ionic compounds contain a cation, which is named first, and an anion, which is named second, of course, and the cation is a metal, and the anion is a nonmetal. All right, second bullet point here. The cation is named the same as the parent element. So the sodium ion is the same as the sodium atom. Same name. The anion, which comes second, is named by taking the root of the parent name or element name, and then we add the ending or the suffix IDE to the end of it. As an example, name the following ionic compounds. A, CSF. B, AlCl3. C, LiH. Cesium fluoride. Aluminum chloride. Lithium hydride. You see the IDE endings. Now, some transition metals, right? We talked about that. Groups 3 through 12. Some transition metals can form cations with multiple charges. And the specific cation must be confirmed by using a Roman numeral. Cr2 plus is chromium Roman numeral 2. Cr3 plus, chromium Roman numeral 3. Fe2 plus, iron Roman numeral 2. Fe3 plus, iron Roman numeral 3. CO2 plus, cobalt Roman numeral 2. CO3 plus is cobalt 3. These are all the popular ones. Cu plus, copper 1. Cu2 plus, copper 2. Sn2 plus is tin 2. Sn4 plus is tin Roman numeral 4. Pb2 plus is lead 2. Pb4 plus, as you might expect, is lead Roman numeral 4. Now mercury 1's kind of a special one here. Hg2 with a 2+ charge is mercury 1. Hg2 plus mercury 2. So the mercury 1 ion there, the Hg2, that's found as a dimer, which is essentially 2 mercury 1 cations fused together, if you will. Okay? So we use Roman numerals nowadays. But metals that form only one type of cation, for example, group 1, Na+, Li+, K+, we don't need to use a Roman numeral for those because the charge is already understood. That's the only charge it can have. So nowadays we use Roman numerals, but for example, name the following ionic compounds: CuCl, CuCl2, Fe2O3, and PbBr2. Well, we know the charges of Cl, O, and Br, right? So we can use those to help us. CuCl is copper 1 chloride. CuCl2 is copper 2 chloride. Fe2O3, iron Roman numeral 3 oxide. And PbBr2 is lead 2 bromide. E, by the way, is calcium bromide. Calcium doesn't need a Roman numeral 2, calcium bromide. So A, B, C, and D, we can use the fact that Cl is always a -1, Br is always a -1, and oxygen is always a -2 when these guys form anions. All right. Let's do another example. Do the following atoms gain or lose electrons to form ions? Remember, right-hand side of the periodic table likes to gain electrons. Metals, which are the middle and the left, they like to lose electrons. So it's basically, is this a metal or a non-metal, right? Ra, In, P, Te, Br, and Rb. Ra loses electrons, In loses electrons, P gains electrons, Te gains electrons, Br gains an electron, and Rb, rubidium, loses an electron. So what we're seeing here in A through F is that metal atoms lose electrons to form cations. Non-metal atoms gain electrons to form anions. All right? Now, here are some helpful common anions that we see all the time. F- is fluoride, Cl- is chloride, Br- is bromide, I- iodide. So those are the halogens, right? Group 17, they like to gain one electron as nonmetals to form anions. O2- oxide, S2- sulfide, and then the last two there, N3- are nitride and phosphide. And we're continuing today with naming ionic compounds and naming covalent compounds. So last time we left off, we learned a little bit about ions, cations, anions, and now we're talking about putting them together and naming ionic compounds. So the first topic for today here on page 1 of our notes, naming binary ionic compounds. So this is continued from the last video. Here's an example. Name the following ionic compounds. A, Fei3, B, Li3N, C, HGO, PbCl2, Fe2O3, Hg2S, CuCl, COS, SR3N2, CSF, Mg3P2, and finally Ag2S. So the first one, iron can have multiple charges, right? So we use the -1 on iodide to come up with iron 3 iodide. B, lithium nitride. We just go ahead and name that one because lithium can only be a +1 charge. C, mercury, Roman numeral 2 oxide. Mercury is Roman numeral 2 because oxygen has a -2. D, PbCl2. We use the -1 on chloride to come up with lead, Roman numeral 2. For E, Fe2O3, -2 for oxygen means iron has to be iron, Roman numeral 3. F, we know sulfur is a -2, so the total on the left for mercury has to be a +2. And since there's 2 of them, it's mercury 1 sulfide. For G, CuCl, copper, Roman numeral 1 chloride. For H, the -2 on sulfur tells me cobalt must be a +2 cobalt. Cobalt, Roman numeral 2 sulfide. I, strontium nitride. J, cesium fluoride. K, magnesium phosphide, and L, silver sulfide. Now those last 4 are fairly quick because we already know the charges on the cations. Strontium group 2, cesium group 1, magnesium group 2. Okay? Last one down here, manganese, Roman numeral 4 oxide, and sodium phosphide. So you really have to do some work when it's a transition metal. You can have multiple charges. Otherwise, you just read it. Cation named first, anion with an IDE ending. So what I was doing there on those examples is I was using the charge of the anion, wasn't I? So it says here in our notes on page 2, often the known anion charge can be used to determine the charge on the cation when the cation can have multiple charges. And the multiple charge, the cations that can have multiple charges are usually the transition metals, and those we talked about last time. We made a big list. All right, so that's it for naming binary ionic compounds with 2 elements. Now we're going to talk about naming ionic compounds with polyatomic ions. For the most part, these are polyatomic anions, except for one, and we'll get to this. So polyatomic ions, these are ions containing a group of atoms, kind of like a chunk that we keep together. So with the exception of the ammonium ion, NH4+, all the polyatomic ions are anions. They have negative charges. So polyatomic ions comprise only half of an ionic compound. Remember, an ionic compound is a cation-anion pair. So polyatomic ions are only 1/2 of an ionic compound. Now, polyatomic ions have special names that you have to memorize. Okay, so you make flashcards or something like that. There are ways for us to group them together to help us learn all the polyatomic ions, but here are the ones that you should know. It's going to make your life a lot easier, especially when we get to writing and balancing chemical equations. So NO3- nitrate, NO2- nitrite. One less oxygen, right? A little skinnier, kind of like the A is fatter than the I in 8 into ite. SO4 2- sulfate, SO3 2- sulfite. PO4 3- phosphate, PO3 3- phosphite. Now we're going to go down a list of some random ones. Random but very common and worth knowing. CO3 2- carbonate, C2H3O2- acetate, which is also written CH3COO. Bicarbonate, HCO3-, OH- hydroxide, very common. CrO4 2- is chromate. NH4+, the only positive ion, that's ammonium. MnO4- is permanganate. Cr2O7 2- is dichromate. Cn- cyanide, and O2 with a 2- charge is peroxide. And the last one down there is hydrogen sulfate, also known as bisulfate. All right, so you can see how I've grouped the top 3 groups kind of separate from the main drag down here. That's because the top 3, nitrate, nitrite, sulfate, sulfite, phosphate, phosphite, very, very common. ClO4 minus is perchlorate. ClO3 minus is chlorate. ClO2 minus is chlorite. ClO minus hypochlorite. Also written OCl minus quite a bit. Now, that little grouping of 4, you can substitute any of the halogens in there. F, Br, I. So you'd have, for Br, you'd have perbromate, bromate, bromite, and hypobromite, etc. Now remember, everybody in this table, okay, none of these are a complete compound. Okay, it says here, instead, they are one part of a two-part ionic compound. All right. Now, a few on here that I didn't mention that probably I should. We'll call it honorable mention. So seldom seen, but worth knowing. HSO3 minus is bisulfite. H2PO4, dihydrogen phosphate. Then we have one last one here, which is HPO4, 2 minus charge. And that's hydrogen phosphate. All right. Those are the polyatomic ions that you need to know. Okay, so let's do an example here. Name the following ionic compounds. So the first one here is Na2SO4. Well, this is just sodium sulfate. The Na is always a +1 because it's group 1. So we don't need a Roman numeral. Sodium sulfate. B, this is iron 3 nitrates. We'll come back to that in a second. C, this is going to be manganese 2 hydroxide. We'll also come back to that one in a second. D, RbOCl. Well, this is rubidium hypochlorite. Rb is group 1. It's always a +1. We don't even have to do anything about looking up its charge. There's no Roman numeral. Same thing right here in E. Sodium carbonate. F, potassium bromate. Potassium is always a +1, group 1. It's understood. We don't need a Roman numeral. NH4Cl, well, that NH4 chunk or clump there is the polyatomic cation, the only one. Ammonium chloride. H, this is sodium bicarbonate, or if you want, sodium hydrogen carbonate. I, this is cesium periodate. In our list we had ClO4 perchlorate. This is just periodate. Now, you see up here on B and C, I have to figure out the charge because my Fe and my Mn can have multiple charges. So I use the known anion charge, balance it all out. I come up with iron 3 and manganese 2. See how I've done that bookkeeping there? All right. Now, not once in any of the naming we've done in this video or at length in the previous video was I ever using prefixes like mono or di or tri or tetra. None of that stuff. No penta, no deca. So down here it says not once in the naming binary ionic compounds section, just discussed in the last video and up to just now, have I ever used prefixes. Prefixes are reserved for naming covalent compounds. All right? So, next page of our notes here, it starts off by saying naming binary, that means 2, naming binary covalent compounds. These will be compounds having 2 elements in them, and because they're covalent compounds, it's not going to be a metal nonmetal. That's ionic. So covalent compounds are defined as compounds formed between 2 nonmetals. This is to the right side of that staircase, right? To the right side of the periodic table, essentially the upper right. And that's to the right of that metalloid staircase. And we're going to go ahead and cover all of that next time. All right, so stay tuned for the next video. Take care. Bye.